Ready to go? Cool. Loud mics. I love loud mics. How's everyone doing? Good? Good day so far? Yeah, awesome. What'd you guys have for lunch? Just curious. Anything really good? Sorry, what was that? It's an icebreaker before we get started. Okay, am I speaking too fast or too slow? Too fast, okay. So my name is Kenny Bastani. I was formerly at Pivotal as a Spring Developer Advocate for 3.5 years. I was a CTO for a while. Decided to go my own way and do some independent consulting with a gentleman named Chris Richardson, who is a mentor of mine. And I gave a talk with him about event sourcing at JavaOne in 2016. And we've been working together for several years. And so we've decided to make it official. And I've created a little brand for that. It's not a company. It's not a startup. It's nothing vendory. It's actually, I generated this logo online for free. So I think I did OK. But it's called Hyperscale. And I like to call myself a research consultant, which is a combination of a developer advocate and a researcher. And so what I've done my whole career really is I've purged myself of my own ignorance by building reference applications. And so when it comes to either applying these practices like microservices actually at a company, which I've done in the past, that's how I got into Pivotal. I was building microservices for a company called Digital Insight, which used to be Intuit Financial Services. And we turned a retail legacy banking application into a business banking application using microservices and a lot of Josh Long. I don't know if you know Josh, but he helped quite a bit. And we delivered 2 weeks early, and we just had nothing to do but write tests, which was great. So I ended up going to Pivotal. So I've had experience both in industry as well as what I call advocacy. And so I write a lot of reference architectures and examples and do a lot of research so that I can come here and present to you and not just talk about what a vendor tells me to say or some kind of like marketing deck. So I make my own decks all the time, my own diagrams. I consider them to be quite beautiful. I hope you do too. So that's me. We talked about me. So I just wanted to say too, microservices.io, if you have not gone to microservices.io in the past, I think that's probably pretty unlikely. If you search for anything microservices, it's going to come up. This is Chris Richardson's website that he started several years ago. And it was right around the time that microservices were coming into the spotlight. It's kind of like serverless 2 years ago. And since then, it's become rather robust. And so I'll go ahead and open that up. Oh, of course. Does anybody know the Wi-Fi password? That's not very secure, but I appreciate it. Great, thanks. Okay, so as you can see, hopefully, that's my quote. I was going to be late to my talk. Oh, you can't see that. That's great. Show mirroring display. Here we go. Okay, you can see what I'm seeing. Okay, so this is microservices.io, and it used to be much smaller in terms of stuff. And so it's become such a knowledge base of information for microservices in the industry. As Chris travels around the world and he gives trainings to companies, large and small, old and new, on how to build microservice architectures, I consider him my Jedi Master, and I guess I'm the Padawan. But he has for years been a great asset to me and a help when it came to me first building microservices and understanding the architecture, and then also when it came to event sourcing and CQRS, which we're going to talk about today. So if you haven't gone to microservices.io yet, there's a lot of great stuff there, including a pattern language for building microservices. And this is the kind of stuff that I'm going to be working on at Hyperscale. So this isn't a pitch. This is really to kind of tell you what you can look forward to if you are not a vendor, if you're not IBM or Oracle sitting in the room, although I kind of like IBM right now. So I call it open brand collaboration. And what that means is I'm not a part of a foundation. We're independent consultants. It's people like Sam Newman, people like Chris Richardson, people like myself, people who can write code and who can write books, right? So I wrote a book called Cloud Native Java with Josh Long. And it's about 600 pages of everything that you would want to know about Spring, the entire Spring ecosystem as of 2 years ago. I think it's all changed now, but there's still some good bits in there. And so we learned a lot from that, just writing that book about what our customers at Pivotal really needed, and it did pretty well. So you can decide to buy it or just email me because I'd love to give you that knowledge. But anyways, that's the whole entire idea. So we're a think tank of independent consultants and thought leaders that have made impacts on the software industry. And we're all kind of evangelists / engineers, right? So this isn't one company. It's really just a collection of people with a really cool logo and an all right name. And it's not a company. It's not a trademark. It's not an open source project. It's a culture and a community of best practices. And so the entire idea is we want to eliminate all of this vendor talk that's being thrown around in these buzzwords, which are being used to sell companies down the road on products that may or may not be good for them. And it all sounds really good up on stage, but I can tell you, working for a vendor, Pivotal's great, by the way, but and especially Spring, one of the better open source projects out there when it comes to frameworks. Who's using Spring today? Anybody? It's wonderful, right? So, but as we're seeing the industry get more competitive on using the same open source projects like Kubernetes and coming out with different distributions, it's like, what is the difference between these different distributions that I'm paying millions of dollars for? And so our goal is to do open advocacy, public research, and provide peer-reviewed software practices. Because after leaving Pivotal, what I kind of learned on a sabbatical was like every other option kind of sucked. Going to a Google, going to a Microsoft, those are all great companies to work for, but they're all kind of competing for the same piece of the pie. And so an opportunity to work with Chris Richardson, who's truly a leader in the industry, and he kind of sits in the shadows writing a lot of content. Who knows Chris, by the way? Yeah, Chris is a wonderful guy, and he just put out a new book about microservices event sourcing. So he's the foremost expert in the world, I believe. I haven't met anybody with more expertise. If you do have more expertise, let me know. But his stuff is quite good. So before I move on, vendors are really ruining the what I call the academia of software by creating their own foundations. So we have like the Cloud Native Computing Foundation, we have Cloud Foundry Foundation. Now Eclipse and the other nonprofit foundations that came before, that's not really the problem. It's companies like Google, it's companies like Pivotal that create foundations that really are meant to drive revenue for products. And that's what puts out a lot of these buzzwords. And so I can say that because I'm not going to get sued. Right now, it's just the two of us, so it's Chris, and I just made up a title for him that sounded good, principal consultant. I mean, we're just consultants. That's how we make our money, is just by teaching, right? So we do trainings. I'm primarily doing research and trainings, and so I have a GitHub repository with countless examples of tutorials and full reference applications. So you can go to my GitHub profile. I'll pass you these links later. We're going to look at one of these today, which is I would say a pretty complex, highly scalable CQRS/event sourcing application. And we're going to see how it runs on Kubernetes, and we're going to look at it with Grafana. Okay. Now, on to the talk. So the title of this talk is The Many Faces of Cloud-Native Java for Event-Driven Architectures, which, I mean, I kind of just made that up last minute. So let's simplify that, revise the title to The Why, the What, and the How of Event-Driven, with a focus on microservices. And the question we're trying to answer is, how do I build and maintain scalable event-driven microservices using something like Kubernetes, for instance, which has become very popular today for running applications in the cloud? I don't know. I like the GIFs. So the agenda is, I'm going to talk a little bit about event sourcing as a history, because there's an interesting history that's going to help people understand how pervasive event sourcing is today, not in computing, unfortunately, but just throughout the world. I mean, we use it in our minds. When we count things in objects, in a sequence, and we add that up to a number, and we store that in our memory, and it actually allows us to keep track of information in an easy way that we can communicate. So like how fast we're going in a car, for example. I'll talk about Apache Kafka and the move over towards kind of taking out the backbone of a database and using that as an abstraction for data in this world of cloud native. Since we now have the resources that scale to demand, we can have something as high throughput as Apache Kafka, which started out as a LinkedIn project. And that immutable log has become a very important part of all of our architectures today. And it's key to event-driven microservices. I'm going to talk a bit about Spring Cloud Stream plus Kafka, because all of my projects are written in Spring right now, but I'm going to also benchmark Micronaut as well as Quarkus. I don't know if I pronounced that correctly, but I'm going to dive into a reference architecture, which is actually an application, an example project with open source code that's reactive end-to-end, so it's the latest technology in Spring, and it even uses Spring R2DBC. I don't know if R2DBC, yeah. So it's basically a reactive driver for JDBC. So you have end-to-end reactive on top of a relational database. And so let's start with a story. So event sourcing has an interesting history to it that goes back as far as time. Now, in 2006, Martin Fowler described it on his website, and it was the first time that I saw the term event sourcing published on the internet. So that goes to Martin Fowler, even though he claims that somebody else coined the term. And he said this. He said, event sourcing ensures that all changes to application state are stored as a sequence of events. Not only can we query these events, we can also use the event log to reconstruct past states. We can determine the application state at any point in time. We do this by starting with a blank state and rerunning the events up to a particular time. Now, this has become a very popular explanation today from companies like Confluent, who are the maintainers and vendors behind the commercial version of Apache Kafka. But I think that for most people who aren't experts in their field, or aren't sitting in this room and saying, I know this stuff already, this is a kind of a hard definition to really deconstruct and say, I know what event sourcing is. And so we have some metaphors. And so I was looking at really the history of who invented event sourcing, because it was ambiguous. Nobody really knows who invented it. There's a lot of people that take credit for it, but there's no clear indication that anybody invented it. Not even like Greg Young started talking about it in 2008, yet Martin Fowler was in 2006. So there's this guy, Edgar Allan Poe, interestingly, a poet, an American poet, very sad. He wrote a lot of poems that not a lot of people really got who he was, but he was first and foremost more of an Einstein before his day. He was a scientist first and foremost. Like, he had a very active imagination, but his entire audience were people that wanted to hear stories. They didn't want to hear about his theories of the universe at the time, because Newtonian physics and basically this view of a Cartesian universe had become ubiquitous. And so instead, he decided to lace inside of his poems, especially his last one called Eureka, his full theory of the universe. And it was quite interesting because as I was looking back at references, I found kind of the same definition as Martin Fowler just written back in the 1800s, which was interesting. So what Edgar Allan Poe said was that we appreciate time by events alone. For this reason, we define time, somewhat improperly, as the succession of events, but the fact itself that events are our sole means of appreciating time leads to the erroneous idea that events themselves are time, and that the more numerous the events, the longer the time in the converse. And so that's interesting because he uses some words like succession of objects, succession of events. And so did Edgar Allan Poe invent event sourcing? Of course not. He didn't invent event sourcing. Somebody who had a problem with a computer invented event sourcing. But it's interesting because when you're talking about understanding what event sourcing is, it's quite simple if you look back in time and you see the connections. Now, who knows, wait, let me go back. Who knows where the term log in computer science came from? Anybody? Got 2 people. Now, logs are ubiquitous, right? We're all using log. Who's not using a log today, right? No one. Okay, so like, isn't it weird that we don't know where that term came from, that we've forgotten, except for 2 people who are probably PhDs? So it comes from this thing called a chip log. Now, a chip log was invented by Portuguese sailors back in the 15th and 16th century. And it is a very neat abstraction of the log that we use today in something like Apache Kafka. And how it works is this. You have a ship, and the problem is I need to measure the speed of my boat so that I can make sure that I get to a destination on time, or I can, fan or paddle faster. So you have an ocean, and you have a ship, and then you have this thing that looks like a fishing reel, but it's called a log reel. And this log reel has this small, tiny, thin rope with equally spaced knots at equally spaced intervals. And you can throw out this, so there's the log line, and here's your knots. You throw out this underwater parachute, right, which drags behind the boat. So you have 2 sailors that are doing this to measure how fast they're going. Now, they didn't have GPS at the time. There was really no way of measuring other than this. And this was actually a pretty accurate way of understanding how fast they were going. Now, what would happen is this. You would have one Portuguese sailor, after a period of time, they'd have a little hourglass or this sand glass that they would flip over, which has a definite period of time or a discrete period of time where the sand drips through the glass. And when it's all done, what they do is they reel back in that log line, and they have the other sailor call out the number, so it counts how many of the knots pass through his hand in that interval. And then they come up with the speed that they're traveling, right? So you can kind of think of each of these knots as events that are passing through the hand of that sailor. And that's really what event sourcing is this act of collecting events and then in a sequence rerunning them to get the current state or speed of the ship. Now, the Poe connection is this. Why Edgar Allan Poe is obsessed with this theory of the universe is that he saw that log line and he had saw other means of measurement, because at the time, measurement was really the big problem. They had no way to really accurately measure things, and so they used objects to measure things. And so he was obsessed with event sourcing, or what we call event sourcing today, for much of his life. He clearly says it in his last poem that he wrote. And in his time, things were commonly measured using a form of event sourcing, like the knots on the log line for measuring the speed of ships, which just so also happens to be the definition of or where the term came from in computer science. And so there is a clear connection between the chip log and what we use today. And so this is a metaphor, and we've forgotten the origin of the term. Now, understanding the origin of the term itself for a metaphor is really important because we're working with virtual abstractions on our machine. And so when you have a developer who thinks they clearly understand event sourcing and they're having trouble explaining that to a colleague, wouldn't it be nice to just pull out a log reel and reel in the knots and say, this is how it works? You can even use IoT devices. I'm sure GCP has some cool stuff to actually turn that into a fun little application. But the entire idea behind it is that you're trying to count the number of events that are happening in time, and you're compressing that down into one meaningful value. Now, most software is built on metaphors, but the problem is that we've forgotten that these metaphors have meaning, and so eventually we can't track back to the foundation to really understand simply what something does. And so a little bit more about Edgar Allan Poe. So in his last poem, Eureka, he talks clearly about the succession of objects, succession of events. I'm not going to talk about Edgar Allan Poe that much anymore, but the ship log itself is really that metaphor, right? So you have the ship, you have time, which is the real, you have space, which is the line, and you have your events or objects, which could be domain objects that happen in a sequence in your application. And what Apache Kafka does is essentially stream that to your application, and you're going to receive event after event in that sequence, and you're going to do something with it. You're either going to measure the speed of something, or ideally, you're going to aggregate it. Now, it takes causal events across space and time, and it summarizes it into a single object, and that's key, one single object that's easier to store in memory. And so that's the fundamental idea behind it when you come to the theory and method. Now, the implementation itself, really we're concerned with the implementation and performance, right? What do I get out of this, and why am I not already using it? Now, all really great software, well, some great software, is built on good metaphors, right? So here are a collection of just a cloud of metaphors that relate to the real world, right? So we have this world of bits and bytes that we actually want to be able to communicate and teach to people, but we really need these metaphors to be able to correctly provide the information or transfer the knowledge that's tacit and virtual so that everybody kind of understands what something means, right? Now, the desktop metaphor was ubiquitous for actually making the desktop PC something that people wanted. Now, if you could believe it, I think it was Hewlett-Packard who passed up the idea of the personal computer from Steve Wozniak and said, nobody's ever going to want a personal computer. And then Steve Jobs came up with the desktop metaphor, and here we are today. Now, these metaphors mean something. There's an underlying abstraction to our own humanity, and it has an intimate connection to the virtual world that we're building. The desktop computer itself replaced actual desktops, and the virtual machine replaced the server by virtualizing the abstract functionality of the hardware, and then containers, and ultimately it's hard to keep track of all the layers, and so we get a lot of confusion. So that confusion is compounding on itself in these layers. It's becoming harder and harder for new developers to break into the market and understand from the very bottom of the stack how things work all the way to the top of the stack. And it's extremely useful to understand these metaphors. And so we get lost in abstraction. And so all confusing software is built on nonsense, and I'm going to tell you today why we argue so much about words. Serverless, there's servers. Why does that make sense? Middleware, anybody argue about middleware? It's a word that doesn't really have a metaphor into the real world. Microservices, actually these are things that we have conferences on for the last 5 years because people still are trying to understand the concepts behind microservices. ESB, that's an easy one. NoSQL, people sometimes argue about that online. SOA, everybody argues about SOA. DevOps, what is DevOps even? My boss, he created DevOps. He doesn't even know. My ex-boss. I'm not saying microservices, DevOps, and serverless are themselves nonsense. They're not. They're very useful things. They just have pretty bad names. Now, DevOps is a pretty good name because it says, I'm just going to smush a developer and operator together. That could mean, go grabbing drinks at the bar later and making friends, or, it can mean many things. And so vendors, they end up giving their own interpretation to these things. People write books about DevOps, and we end up getting confused. And so we create DevOps leads, DevOps engineers, and we get away from the entire practice of communicating between developers and operators. And so what I'm trying to say is that metaphors make good ideas more durable to just nonsense. So this is a log. This is the very first log. This log came a lot later. And this is a log itself. And it actually is a log. It's not that much of a joke. If you look at the rings on a tree, right, you can tell how old the tree is, right? And so what is that? It's event sourcing. So you can see clearly that this log has these circles in which you can actually count the number of circles to see how many years that tree has survived for. And so you can count the age of the tree. And so that's probably why they call it a log. Now, we're going to talk about some virtual logs now. We're going to get into some good stuff. I hope I have enough time. I like to talk about the theory a lot, but a lot of people really kind of want to get into the good stuff. And so I'm going to try and jump in there right now. Now, Apache Kafka, who is using Apache Kafka today? Right, that's good. So I'm going to breeze over this stuff because I just explained how it worked in the metaphorical sense, time-ordered events. What you're going to do is you're going to use essentially these events that you're going to receive from your end users that are domain events, and you're going to sequence them on a stream, and you're going to be able to kind of rewind and replay them whenever you want, which allows you to generate a time machine essentially to come up with the state of a system or replicate the state of the system at any point in time. Very useful. And it's the same thing that we did with the chip log, but just way before software. A better example is Street Fighter and GIFs, very popular. That's event sourcing as well. And so you've heard all about event sourcing, but how many people are doing it successfully today in the cloud? Just curious. One, right. And so I'm glad that I haven't gotten too old. So event sourcing, why we're not using it today is in a later slide, so I'm going to explain what it is. So event sourcing, the usefulness of it is that these aggregates can be used to generate the consistent state of any object, kind of like a time machine. And, or you can look at it as a symphony, which I think is a lot more beautiful of a way to describe it, is that each one of these notes in the symphony represents these events that are happening in parallel. When you put the entire thing together, you get this orchestra. And it also provides an audit trail that can be replayed to generate the state of an object at any point in time, like a time machine. But you get some side effects for this, right? There's actually some benefits that you get that you didn't intend to get. Now, when we build something like event sourcing into our system, and we have legacy bits laying around, and there's all these new concepts, and doing it the right way, without losing your job because something fails later on, or just, you know, if you work at a good company, just getting a slap on the wrist and then being able to fix it. There's a lot of risks for implementing event sourcing, right? It's a very complex thing. It adds way more complexity to your microservice architecture than you added from your monolith to microservices. But what it does give the business is it gives them the value of being able to analyze the event data for stream processing and machine learning. And then it also allows you to roll back transactions. And so as you go to this distributed system of many different applications communicating over the network, that network is going to fail from time to time. And so you need to be able to ensure the consistency of your transactions because everything is going to be eventually consistent. And that doesn't mean that it's a guarantee that it'll be eventually consistent. That just means that's the best you can get. And so that's a common point of confusion for people. They think, oh, because microservices are eventually consistent, they get that out of the box. But no, you can actually write a defect into your code that completely screws up everything, and you have to have a human go back and fix it, usually a DBA, and that's why they're so angry. And so why aren't we doing it everywhere is the question, right? There's one person in the room who raised their hand, and the answer is we are really doing it everywhere, but the question about, the larger question about microservices is that we're not doing it because storing state as an immutable log of events for domain data didn't make sense in a time BC. Now, I'm not going to go and talk about history again. It was just a funny joke that the inventor of DevOps told me one day. 15 minutes. Okay, I got to go a lot faster. So we know about Kafka. The immutable log essentially came from your highly available databases, and so I use a zipper as a way to explain eventual consistency. And you have a primary, which you write to. That's going to be your source of truth. And you're going to have your replicas, which are going to take those operations in their sequence, and eventually it zips up all the way, and it becomes atomic, and it becomes consistent when those zippers are all the way up, and so you can query it from it. Now, I'm going to skip through the Apache Kafka and Spring stuff because I do have open source examples and tutorials of that, but I want to get into the rest of my content. So why do we need event-driven microservices? And that's because there's no foreign key constraints between microservices. It's pretty simple. You have a domain, right? This is what the business sees. They see interactions and value between objects in their supply chain, in their ERP system. Essentially, they're building a machine to make money, and you're building a machine to make them money. That also costs money. And what we have here is a very simple abstraction of what that is, and we can actually traverse these nodes, and we can make sentences out of them, and a business person doesn't need to get a degree in computer science to understand what a relational database is, or a schema. Now, this is a much, I guess a business person could still read this, but this actually then goes into the impedance mismatch area where you're trying to take something like this and translate it into a schema that already exists and modifying it, and it becomes a pain. Now, when you take that monolithic database and that monolithic application, and somebody tells you you're going to speed up and go a lot faster in your development process if you just break everything and split apart everything, your DBAs are going to pull their hair out because we've already been doing that for a long time. And what the essential problem here of why we need events is because we need a way to efficiently join together data without having to use HTTP, right? So if we make calls across the network, we're going to incur a cost, and that's going to slow things down, especially if it's using blocking communication. And so a clear reason why you shouldn't do it is it's just very slow. So you can probably just call 2 microservices or 3, depends on what your SLAs are, and you can join together that data. That doesn't hurt so much. Where it hurts is where you have to do a recursive read from a service, where you're calling that service to call another service, and then calling back to that service, and eventually the network comes down. And distributed transactions are the opposite of that. That's writing. And that's going to cause an inconsistency without a doubt, because the network itself is not infallible. Now, when you design these architectures, you're going to want to use something called domain-driven design, which a lot of people have read the book DDD by Eric Brewer, and then there's also other people who have written books after that. There's a lot of really great developer evangelist advocates out there and consultants. Michael Plude from Germany happens to be one of them. He works in NIQ, and he gives brilliant talks on DDD. Chris as well. And this goes into something called event storming, which is the domain-driven design way to really build this domain model. Now, you're going to have these contexts, and inside these contexts, you're really going to have these domain objects, right? So we're still looking at that business map. And in orange there, what I can do is I can arrange my applications in any configuration that I want, as long as one of these objects belongs to an application. Now, I would just take that orange diamond and put it all in one application. I would take the red triangle that's upside down, put it in another application, inventory and catalog. And now I need to figure out how to do these queries, right? So I need to be able to look up orders and credit cards and accounts and connect them together. Now, we use something called CQRS to do this in a performant way. What we do is we turn the API essentially into a constraint that allows us developers to easily execute the collection of events and then the aggregation of those events into these views that we can pass off to our front-end developers at the business. Now, it stands for Command Query Responsibility Segregation. And it's just really an API constraint. So we have our commands that come in. You're going to structure your API as a collection of commands on objects. Now, anything that writes to your database is going to be an API call that comes through as a command. And so if I have an account domain object, I'm going to be able to mutate it by calling the suspend command. And that's going to update the status of the database for that account to suspended, or it's going to say, sorry, you can't suspend that person, it's already suspended. And then you can then query that account just the way that you normally do. And in the middle of all of that action, you're going to generate an event. And so we're going to look at a system architecture that I put together that runs on Kubernetes. You can basically hit a few buttons and get Kubernetes running up on your desktop if you don't already have access to a Kubernetes cluster. And it's going to give you everything that you need except for a 12-gigabyte laptop. So you're probably going to need some memory in your laptop to run it. And so breaking this down, I have two separate applications. I have a command side and a query side. You don't have to do that. You can put this all in one application. So let's look at these as component modules because it makes more sense. So this is the command API, right? And it's going to generate commands, it's going to provide commands to the end user or the user of your API, things like suspend account, and that's going to generate an event like account suspended. And then we need an event store, which is essentially this message broker combined with a database to be able to store that sequence of events and then dispatch and broadcast these events to all these other services. And then we're going to have a collection of event processors. Now, event processors can be embedded anywhere in your application. They're consuming a topic, and they're going to receive events in the sequence that they are sent. And so that's the guarantee you get with Kafka, and that's why a lot of people use it. It provides the guarantee of item potency and ordering of events, which is great. And it's because it uses Apache Zookeeper. So these events are broadcasted to other services, and those other services are able to turn those events into materialized views, which are just single object representation, going back to that reel of these knots. It's just basically counting the number of something. And it gets more complex than that, but what you're doing is you're taking a business requirement in a very difficult architecture with complex API calls that you've designed yourself for God knows why, to go faster because somebody else told you to. And you need to be able to generate these materialized views because the system is just going to be way too slow otherwise. And so you're going to build your query models, which are lookups, very fast, and you can cache them. And so here's what the entire thing looks like together. Now, if you want to separate out these things into separate applications, you're going to want to put a nice, clean, shiny API gateway on top of it, which is going to hide all of those implementation details down below from your consumers so that you can change things down underneath the hood whenever you need to. It's like changing out something in the engine of your car. And your steering wheel still works and looks great. And that's the main idea. We want to make sure that the user of the application isn't going to have to deal with any of the side effects of us changing our architecture down below. Okay, cool. So we're on time. So we have a reference architecture. The question we want to answer, the application we're building here is a social network. Let's say that we're Facebook and we just got started today and we want to build our application with microservices because it seems like a trendy idea. And so how do you do a friend of a friend query with microservices? Now that's a tricky question because a very simple looking domain here, I have just users and my friend relationships. Everybody knows this, right? Even if you're not on Facebook, even if you don't use a social network, you have relationships with people in this room, right? They're not visible connections that you can look up in a database, or maybe they are. But this is a very unsuspecting domain model because it looks very simple with two objects, a relationship and a node. But when you have an impedance mismatch and try to separate this across the boundary of the network, things get a little messy. And so day one of building microservices looks like day one of Tony Stark building, well, I guess this is day two, but building his Iron Man suit and shooting some lasers out of his hands. A lot of fun. So you're like, okay, my teams have built their purest domain services. I can store my friend relationships in the friend service. I can store my users in the user service. And then somebody on the front end team says, hey, we're going to need recommendations because those are really important because we want to be able to collect people's phone numbers and then build a graph, and then we want to be able to make sure that you can friend somebody that you knew in elementary school. And you're like, okay, this looks very difficult. Now I have to query the friend service to get all of their friends, and then I need to go back and look up every user and then look up their friends, and then I need to run some analytical query. And I have to do that each time a page loads. Not a good idea. And so that's why we build materialized views. It's a very good idea. And so this is the basic abstraction behind all of the CQRS/event sourcing architectures in the simplest form I can represent. You have domain services and you have aggregate services, two very different things. Your domain services are going to be pure business logic. Your aggregate services are going to do all the things that are kind of crazy ideas by the business, like recommendation queries. Not so crazy, but too crazy to like figure out how do I put that in my friend service or my user service as an API. And so I'm going to put that into a different service that's read-only. And so I'm going to pump my commands into the user service and friend service. Those are going to generate events. The message broker in the middle is going to pick that up. The aggregate service is going to consume that sequence of events in order, and it's going to build one single view of all of your data across your microservices so that you can query and do a recommendation query on that data itself in a very quick way. So closer view, you create aggregate views from your event data, and you can create read-only, eventually consistent replicas, just like we do with our highly available databases that are read-only. Now, if you don't do this, you're going to have something called a distributed monolith. You're going to end up coupling your services together, 80 of them or so maybe, if you're unlucky, and then you're going to have to deploy 80 services at the same time every year or something, eventually. And that becomes a major mess, and then consultants have to come in and clean it up, and then they give up. It's a very difficult and complex problem. Software is very hard, especially when you get to that level of complexity where the end user is critical and they can't have the service go down. And so this is why it's very important to start to look into this before you build microservices. Now, very simply, domain services are microservices that own the system of record for a portion of the application's domain. You know, they're going to have a product manager who's an expert at that part of the domain. We saw the domain graph earlier, and that's going to have a product roadmap that stays clean, and it makes it easy to query. There's not going to be a lot of complexity in there. This is where your complexity is going to grow. It's going to be in your aggregate services. These are all these dirty queries that we need to join up 5 or 10 different microservices together. And the only way to do that efficiently for every single page load is to figure out some really awesome caching strategy that uses an acyclic directed graph, or you can build an aggregate service, and you can collect these events and then join them together. Now, Eventuate simplifies this. Now, you have Apache Kafka, but Apache Kafka doesn't solve one problem itself very well, and it's called an application dual level write. So this is kind of the same thing I showed you. This is Chris's diagram, but the big difference here is that you have an event store, a true event store, which is going to solve this problem of an application level dual write. Now, I happen to believe that in almost any case on Kubernetes that if you're running Linux, you have something called POSIX, which is going to send signals to your containers and your applications inside those containers when they are going to be shut down or if they crash, which will then send a message to your Java process saying you should clean up before I shut you down. And that's going to handle the in-flight connections, the in-flight transactions that you have running. So that's my view of the world. So this actually, I've tested this at scale. It works for application dual writes in the way that I've done it. But Chris swears that one time there's going to be like one piece of data missing, and I trust him, because there was this thread that was 42 comments long on my repository of a lot of people jumping in, a lot of experts, a lot of the leaders in the world on this subject who wrote some of the most fundamental libraries. They chimed in, and we didn't really come to a solid conclusion other than the fact that application level dual writes are theoretically inconsistent and can cause inconsistencies that you'll never find out. And so the original bug report said that the friend service tries to do an atomic operation across 2 different data sources. It's when I'm trying to write to my database and to Kafka at the same time. And you never know if the database is going to be available or if Kafka is going to be available, but you need these 2 things to be available in a single operation. And if one of them is unavailable, you're going to have an inconsistency. And so that's the problem. Now, Eventuate solves that problem because, 2 more minutes. Okay, I'm almost done. Eventuate solves that problem because what it does is it actually uses something called change data capture, which allows the database to connect directly to the application. In the event store itself, it is running a Spring application that's connected to a MySQL database as well as Apache Kafka. And it's able to use this direct connection between Apache Kafka and MySQL to collect those events. And so you have one application writing to another, and so if it goes offline, then you don't write. Now, I have an open source example that I have running on Kubernetes, and since I'm out of time here, we'll just hope that it is up and running. Now, this is the repository for it. It's, that's not it. No, it is, okay. Now, this is a really thorough tutorial, so if you didn't catch what I had to say in 40 minutes, that's totally understandable. But I have a full tutorial here on this repository, so you can go to github.com/kbustani, or just look me up on Google, Kenny Bustani, and you can find this repository, and it is an extremely thorough explanation of how to run Kubernetes, how to run event sourcing, how to run a social network on an event-sourced architecture. It uses same things I talked about today, and here's the actual diagram for it. And so you can check this out yourself. It has the API gateway, it uses the discovery service, and you have your friend recommendation service. And so it fully explains this architecture. Now, I'm going to replace this component here with Eventuate, as well as swapping out the Spring applications for Micronaut and Quarkus. And Chris and I are going to publish the results of what we find. So how hard it is to actually migrate those applications, and we'll post those metrics. You'll actually be able to run those metrics by yourself, because if I go to localhost 3000, or 8080 rather, I should have Grafana running. And so if you go to my command line here and you run a K8 git pods namespace social network, you're going to see that I have all of my containers running in Kubernetes. That's kind of hard to see. But I have 3 instances of Apache Kafka running, as well as 3 instances of Zookeeper, and I can auto-scale up my other services as well. Now, if I go to the directory for my application, there's going to be a shell. Oops. There you are. So there's going to be a shell script here that's going to ping the user service and the friend service, and it's going to start creating users, and then it's going to create their friend relationships. And so if they're already friends, because it's a randomized process, it'll come back with an error. And you can actually observe this process happening live in Grafana. So if I go to Manage here, you can see that I have 2 different dashboards. I have my JVM information, so I can see all the information about all of my services that are running, and I can see how they're handling that load over time, so it's very useful. Now, this is a very basic dashboard that uses Micrometer IO, which is a part of Spring Boot 2.0. And then I have one more dashboard here. I know I'm out of time, but this is the last thing I'll show you. And so let's go ahead and take a look at what's going on and set the refresh interval to 2 seconds, and we're going to see what happens here. And let's up the ante. We're going to do a parallel. Now, I created like an insane script that parallelizes, it tries to DDoS the system. As you'll be able to see, actually, right now it's actually creating those users. So if I go back to the dashboard, I should be able to see some action. Let's go last 5 minutes. So here's the users that are being created. And you can see them here. And I should be able to see the refresh. That's great. Apply. Oh, thank you. Yeah, it's free. Yeah, yeah. This dashboard's free. I designed this dashboard, and you're free to use it. It's in, permissive license. All this stuff I showed you today is free. And you can deploy, so this uses Helm, so you can deploy to any Kubernetes cluster like in the world. So any Kubernetes cluster that supports version 1.9, I think, you can use Helm to deploy this entire application to it. And it can become just your working model for how you understand how to use both Kubernetes, how you benchmark your Java applications. Now, this dashboard itself is really a bad idea because what it does is it actually queries the database. It queries PostgreSQL to query how many users every couple seconds. And so what I need to do is add in a Kafka dashboard that's going to read the throughput of events. That way, I'm asynchronously observing the system instead of actually interacting with it. So that is my talk, and I don't have any more time, but you can just find this at this URL here. Oops. I don't know how I'll send it. If you follow me on Twitter, I'll tweet it out. If you want to take a picture of it, if you want to come and ask me, just Google me. Just like Google Kenny Bastani event sourcing, and maybe you'll find it. If you don't, then tweet at me and say something. All right, well, I thank you all for being patient and listening to this talk. Thank you for having me. It's great to be here in the Ukraine. It's great to be in Kiev. It's my first time here. It's been a wonderful experience. And I take off on Sunday. So if you want to have a beer or something, I would love to hang out. Or if you want to have any questions here up on stage after we cut officially, I will answer them. So thank you very much.